Okay, here we are going to be graphing rational functions. You should look through the PowerPoint I have on this 8-step process, depending on how you count. It's a big, long process. Here I'm just going to be applying all of those steps. So say we want to graph this perfectly good rational function here. First step we want to do is find the domain. So number one, domain. To find the domain, take the bottom, the denominator, say it's not allowed to be 0. Technically, our first step is factor top and bottom. The only thing we could factor out here is a 3. Nothing's going to cancel, so I've kind of skipped that step. So we take the bottom, set it not equal to 0. X then is not allowed to be 4. So our domain is all real numbers except for negative infinity to 4, 4 to infinity. That's the domain. Okay. Notice I have two different sections of domain. That means I'm going to have two different sections of graph that don't touch each other. I'm going to go ahead and call these guys section 1 and 2 now. I'll need that in a minute. Okay, step 2, find any asymptotes. So let's find any vertical asymptotes first. To do that, we take the bottom, set it equal to 0. Vertical asymptotes, take the bottom, set it equal to 0, and we get x equals 4. That's the same thing we just did right here. Finding the domain, finding the vertical asymptotes are the same work. We just write the answer a little differently. We get x equals 4. Vertical asymptotes are vertical lines, and they're always x equals a number. Okay. I think as soon as you find something, you should put it on your graph. So I'm immediately going to start graphing. I found something, I'm going to put it on the graph. So x equals 4. Drawing a vertical line. All right, there's going to be my vertical asymptote. It's just a dotted line. Okay, next step, find any horizontal asymptote. You can label, don't stress about, well, this is step 1 and this is step 2, and don't worry about numbering your steps. I'm just doing that for ease here. Sometimes I'll call this step 3, sometimes I won't. That doesn't matter. The point is we need to find our asymptotes. For horizontal asymptotes, I look at the degrees. The degree of the top is 1. Degree of the bottom is 1. It's the same degree. So the horizontal asymptote is y equals the ratio of leading coefficients. I take my coefficients here, 3 and 1, and make a fraction out of them. 3 over 1. Which of course is just 3. So my horizontal asymptote is the horizontal line y equals 3. As soon as I find something, I put it on my graph. So here, y equals 3. Horizontal asymptotes are horizontal lines. Y equals 3. Okay. Notice here that my vertical asymptotes separate my x-axis into two regions. All of this stuff over here, that's what I called region 1, and all of this stuff over here. So this whole section, all of this, these x values are negative infinity to 4. That's what I called section 1. And these x values are 4 to infinity. That's what I called section 2. So I'm going to have a chunk of graph over here and a chunk of graph over here. We're never going to cross a vertical asymptote, so my graph is going to either come down like this and approach this vertical, or come up and approach this vertical. Similarly, I'm going to be approaching this horizontal asymptote. So maybe the graph is going to look like this over here in section 1, or maybe it'll look like this. maybe the graph will come up and cross over this horizontal and right on top. But there aren't a lot of choices. Similarly over here, the graph might go like this, right in here in this little corner. It might look like this down here in this corner. It might come from above and cross over the asymptote and then right on the bottom of it. These are all things we're going to check for. But from this moment on, it's really just excluding things that are not possible to figure out what the graph must look like. Okay, so our next step. Honestly, from this moment on, all we're doing is plotting points. Like everything from here on out is basically just plotting points. So the easiest points to find always are intercepts. We look for the intercepts. Okay, so x-intercepts, how do we always find x-intercepts? By setting the function, setting y equal to 0 when solving. So set the whole function equal to 0. Okay, here's a trick that's going to serve you well. The only way a fraction can equal 0 is if the top equals 0. The bottom plays no role here. 0 divided by anything is 0. So all I have to do is set the top equal to 0. So 3x minus 6 equals 0. 3x equals 6. X equals 2. Now, what am I looking for here? We have to be careful here. I'm looking for an x-intercept. Intercepts are points. If I left it like that, that's a vertical line. Intercepts are not lines, they're points. My x-intercept will be the point 2, 0. So to find x-intercepts, you set the top equal to 0 and solve. Make sure to write it as a point. Vertical asymptotes are bottom equal 0. Intercepts are top equal 0. Okay, y-intercept. How do we always find y-intercepts? Always. We plug in 0 for x. So we'll get 3 times 0 is 0. Minus 6 is negative 6. 0 minus 4 is negative 4. That reduces to 3/2. So my y-intercept is the point 0, 3/2. I'm going to put these on my graph. As soon as I find stuff, I put it on the graph. If you wait until the end, you just got too much stuff going on. It's hard to figure out where all your information is. So let's see, we had an x-intercept at 2, 0. And a y-intercept at 0, 3/2. 3/2 is 1.5. So right there. Okay, now I'm almost done. Think about this for a second. Is it possible that my graph, remember I've got these asymptotes here, the graph is always going to live inside the asymptotes. There's no way the graph could live up here. That's just not possible. Because I've already got these points down here. The graph has to hit these points. So the graph could not possibly live up here because then I would have points on top of points. I would fail the vertical line test. We're graphing functions. These better pass the vertical line test. So the graph is going to have to live down in this region. Now, it's possible maybe the graph does something crazy, like it goes, woo, comes down, hits these points, and then bounces back up. So that's the next thing we're going to check for. We're going to determine if the graph ever crosses this horizontal asymptote. So that's, I guess we're calling that step 4 here. Again, don't worry about the numbers. Sometimes I'll number these differently. That's not what matters. This is the order we want to do things in. We determine, does the graph cross the horizontal asymptote? Question mark. Sometimes they do, sometimes they don't. To check that, we set the function itself equal to the horizontal asymptote, and we try to solve. Okay, so my function was 3x minus 6 over x minus 4. My function was y equals that. My horizontal asymptote right here was y equals 3. So y equals the function, y equals 3, the asymptote. Set those equal and try to solve. Okay, this is just a proportion. Just a fraction equals a number. I would cross multiply. Take that x minus 4 and multiply it over. 3x minus 6 equals 3. X minus 4. Distribute over here. 3x minus 6 equals 3x minus 12. Okay, solve that. Pause the video. Go ahead, solve that. Oh, something funny happened, didn't it? Those x's cancel out. I get negative 6 equals negative 12. And your first thought is, you did something wrong. No, you didn't do anything wrong. This just never equals this. I didn't say we were going to solve. I said we would try to solve. We couldn't. There's no solution. When all your x's cancel out and you get some false statement like that, that means no, we do not cross the horizontal asymptote. This was a yes or no question. The answer is we do not cross the horizontal asymptote. Okay, and then the last step is plot any additional points you need. Usually, remember how we had our domain broken up into sections? Normally you need 1 point at least per section. I'm going to argue in this case we don't need anything else. I've got enough information to graph this guy. Okay, so let's look at what we have. Remember, you're never, ever, ever going to cross a vertical asymptote. Sometimes you cross horizontals, but here we don't. Is it possible that over here in section 1, this stuff that's not covered, that the graph lives up here? No, there's no way because I have to hit these points. Okay, could the graph possibly do something like this? Come up here and then come backwards. No, that would not be a function. Look at that. If I graph like this, that's not a function. Plus, I have to hug this asymptote. The graph either has to come from above and hug this asymptote from above or from below. So could the graph come up, hit these points, and come on top of the asymptote? No. I just said we're never going to cross this asymptote. That was the last step. So this graph has to hug the vertical asymptote, has to hit these points, has to come down, get closer and closer to this vertical asymptote, has to get closer to this horizontal asymptote. Section 1 is done. The graph has to look like this. What about over here in section 2? Could the graph look similar, be kind of like that reflected over here? Could the graph live right here? Well, if it did, I would have an x-intercept right there. Look, if the graph is in here, boom, x-intercept. I know there's not an x-intercept there because I didn't draw a dot right there. I found all the x-intercepts. There are none right there. Okay, could the graph go like this? Come up and cross over the asymptote? No, we don't cross the asymptote. We've already figured that out. The only possible place the graph can live over in this section from 4 to infinity is up here in this corner. If you can't immediately see that, that's okay. Plot some points. That's the last step, is plot as many points as you need to convince yourself what the graph is going to look like. Okay, so this one is done. That is the graph of that function.